Hi, and welcome to this new lesson. In this video, we're going to learn how to create a TXY diagram, a temperature versus composition diagram, using Aspen HYSYS. Our goal is to analyze a mixture of water and ethanol at constant pressure and see how the boiling point of the mixture changes depending on the amount of ethanol in the mixture. Let me explain what that means with a simple example. If you have 100% pure water, it boils at 100 degrees Celsius at 1 atmosphere. If you have 100% pure ethanol, it boils at around 78.4 degrees Celsius at 1 atmosphere. Now what happens if you mix water and ethanol together? The boiling point of the mixture depends on the ratio of the two substances. But this relationship is not linear. It doesn't just go in a straight line between 78 and 100 degrees. Instead, it forms a curve, which we can plot in Aspen HYSYS using the TXY diagram. This diagram is especially important in distillation and separation processes because it shows us how the liquid and vapor compositions behave at different temperatures. In this lesson, we'll set up a water-ethanol system in HYSYS, use the case study tool to calculate boiling points at different compositions, plot the results as a TXY curve, and briefly interpret the results. So let's go ahead and get started. Start a new case. Select water and ethanol as your components. For the fluid package, select NRTL or Uniquac, as they're more accurate for polar mixtures like water alcohol. But to keep things simple, here I'll use NRTL. From the object palette, drag a mixer block into the flowsheet. Double-click on the mixer block. In the Design tab under the Connections section, create two inlet streams by typing water, then typing ethanol. These will be the two feed streams to the mixer. Then, in the Outlet section, type Mix to create the outlet stream. Then go to the Worksheet tab of the mixer. In the Composition section, for the water stream, type 1 for the mole fraction of H2O, and leave the ethanol mole fraction empty. For the ethanol stream, type 1 for the mole fraction of ethanol, and leave the water mole fraction empty. Then go to the Conditions tab. Set the temperature to 25 degrees Celsius and pressure to 101.3 kilopascals for both the water and ethanol streams. Next, for the mass flow rate, type 0.2 kilograms per hour for the water stream and 1 kilogram per hour for the mixed stream. HYSYS automatically calculates the ethanol flow rate as 0.8 kilograms per hour to satisfy the total mass balance. This is a simple trick I use to simulate different mass fractions of water in the mixture. By keeping the mixed stream's total mass flow fixed at 1 kilogram per hour and changing the water flow rate between 0 and 1, I can easily study how the boiling point of the mixture changes with composition. Now add a heater block from the model palette. Then double-click on it. In the Design, Connections section, for the inlet, select the mix stream. For the outlet, type boiling. This creates a new stream called boiling as the heater's outlet. And for energy, type E. Next, go to the Conditions tab and set the vapor value to 0. By doing this, HYSYS calculates the temperature at which the liquid just starts to boil. Essentially, the boiling point of the mixture at the given pressure and composition. Now we need to specify the pressure drop across the heater block. To do this, go to the Design tab, then to the Parameter section, and set delta P to 0. This means there is no pressure loss in the heater. Now the warning is resolved. If you go back to the Worksheet tab, you'll see that the temperature of the boiling stream is calculated to be around 79 degrees Celsius, which is the boiling point of the current water-ethanol mixture at that pressure. Since we want to calculate the boiling temperature of the mixture at different mass fractions of water, and to make this process easier without needing to open the stream and check its temperature every time, I right-click on the boiling stream in the flow sheet and select Show Table. This way, the stream properties like temperature and flow rate are always visible on the main screen, and we can monitor how the boiling point changes as we adjust the water mass flow. I double-click on the mixer and set the mass flow rate of the water stream to 0. As you can see, the boiling point of the boiling stream automatically updates to 78.16 degrees Celsius, which is the boiling point of pure ethanol at 1 atmosphere. If I now set the mass flow rate of water to 1, that means it's now a pure water stream, and you'll notice the boiling point rises close to 100 degrees Celsius, which is the boiling point of water at 1 atmosphere. Of course, I could continue doing this manually for different compositions, but instead, I prefer to use the case study tool to vary the water flow rate from 0 to 1 and automatically capture the boiling point at each point. Let's now automate the composition scan using the case study tool. Click on the case studies, either from here or here. Click Add. For the independent variable, click Find Variable. Choose the water stream. Select the mass flow rate. We want to vary how much water enters. For the dependent variable, click Find Variable. Select the boiling point stream. Choose temperature as the output. Set the range. Start 0.0. End 1.0. Step size 0.05. Click Run. After running the case study, go to the Results tab. You'll see a table showing water mass flow versus boiling temperature. You can copy this table into Excel for plotting the boiling curve, or click the Plots tab inside HYSYS to see a live graph. This is boiling point of pure water, and this is boiling point of ethanol. The graph shows the non-linear relationship between composition and boiling temperature. This is a great demonstration that the mixture is non-ideal, and the boiling point changes according to the interaction between components. So, in this lesson you learned how to prepare a binary liquid mixture in HYSYS using a mixer, how to simulate the boiling point using a heater with vapor fraction of 0, how to use case study to systematically vary one input and collect outputs, how to interpret the boiling point behavior for a water-ethanol mixture. This example gives a simple but powerful demonstration of phase equilibrium behavior in mixtures. Before we wrap up this lesson, I'd like to give you a few optional ideas you can try on your own if you'd like to go deeper or challenge yourself a bit further. These will help you better understand vapor-liquid equilibrium behavior and how Aspen HYSYS be used to explore thermodynamic concepts in more detail. In this lesson, we used mass flow rates to define the composition of our water-ethanol mixture, but you can repeat the exact same steps using molar flow rates instead. To do this, go to each feed stream, water and ethanol, and instead of entering mass flow rate, change the flow specification to mole flow. Set one of the flow rates to a fixed value, like 0.5 kilomoles per hour, and leave the product stream flow rate fixed at 1 as well. HYSYS will automatically back-calculate the second feed stream flow rate, just like before. Try this and compare your boiling point curve to the one you obtained with mass flow rates. Does the shape of the curve change? It shouldn't, since composition is what's important, not the units you use. But it's a good exercise to reinforce this concept. So far, we've focused on calculating bubble points, by setting the vapor fraction in the heater block to 0. But you can also investigate dew points. Set the vapor phase fraction to 1 instead of 0. Run a case study on the same range of compositions just like before. This way you'll get the temperature at which the mixture fully condenses, the dew point for each composition.